The key pieces of equipment for doing a titration are a pipette to precisely measure out the solution to be titrated, and a burette to deliver the reagent solution to be added, which is called the titrant. Fill the burette with fresh reagent. Place a beaker under the burette, turn on the tap and run out the reagent until the meniscus reaches the 0 mark or a lower graduation mark that can be viewed easily. Sometimes lighting effects can make it difficult to judge the position of the meniscus. To overcome this problem, some burettes are made with a coloured strip down them. The strip appears to narrow to a point behind the meniscus. This gives a consistent and precise indication of the position of the meniscus. A simpler alternative is to use a piece of black and white card, which makes the meniscus completely dark and easy to read. Whether such aids are used or not, always have your eye level with the meniscus and read the position of the bottom of the meniscus. If the meniscus lies between calibration marks, estimate its position. In this case, it's 4.61. Record the initial reading. Touch the tip of the burette against the side of the waste beaker to remove any small drop of liquid that may be hanging there. Position a white tile under the burette. Add a few drops of indicator to the solution to be titrated, in this case an alkali of unknown concentration. Methyl red is yellow in alkali and red in acid. Tilt the flask to position it so that the burette tip is well below the rim of the flask. Start with a rough titration of the contents of the flask against the standard reagent in the burette, in this case a standard acid. Grasp the burette tap with one hand so that your fingers go round the stem of the burette and support it. Gently swirl the contents of the flask using your other hand and add the solution from the burette in a steady stream. The local change to red, where the acid is concentrated, is easily observed against the white tile. As the titration proceeds, the red colour spreads out, giving warning of the approaching end point. Reduce the rate of addition, but in this trial run, don't waste time trying to determine the end point exactly. When the solution completely changes colour, stop titrating and record the new burette reading. Note the total amount of reagent solution added and prepare for a fresh, accurate titration. Repeat the titration procedure, but this time add the reagent quickly until a volume has been delivered that is 2 to 3 cubic centimetres less than the amount used in the trial titration. Now reduce the rate of flow to about 4 drops a second and gently swirl the contents of the flask. As the area of local colour change begins to grow, slow down the rate of delivery. When a single drop causes a large area to change colour, the end point is close. Now wash the sides of the flask with distilled water to make sure that any splashes of reagent are transferred to the bulk of the solution. For maximum accuracy, now add the reagent half a drop at a time by letting a drop begin to emerge from the burette, closing the tap, touching the droplet on the side of the flask, and washing it into the solution. In this case, the end point is achieved when the red colour persists for 10 seconds. Most endpoints are stable, but some revert for a variety of reasons. In this situation, it is vital to complete each titration quickly. Find the position of the meniscus, keeping your eye level with it. Note the reading and record it. The titer is the difference between the final and initial readings, and so depends on the accuracy of both readings. Repeat the titration procedure as often as necessary to get 2 titers within 0.1 cubic centimetres, These can be averaged and used in your calculations.